town to town, from London to Taiwan. I've been all around the globe trying to protect your soul.
I hope you find what you've been looking for. Trust me, I don't wanna feel no more.
What's up, everyone? So, today we will see the talk on car hacking. I hope my voice is clear. Let me know if you having any problems with stream output. I'm directly streaming from a OBS. This is not a Zoom call. Okay, so this is gonna be direct live stream from my own machine. So yeah, I'm doing this from behalf of Plymouth community. I'm very thankful for folks in the Plymouth, yeah, to be invited here and give a talk about car hacking. So this is the very basic talk, like nothing more advanced level stuff we will see. We will just learn about a very well-known protocol in car hacking, which is a Canvas. So Canvas is a decentralized peer-to-peer kind of protocol which we use to communicate the communication in between the devices in your actual car. So yeah, so this entire thing is based on my blog post. You can check it out on my website cjackers.net, and yeah, we will see it hands-on on from my system as well, like how you can set up all the stuffs, what will be the commands for that, etc, etc. So yeah, let's get started. Everyone, you can see my Kali Linux screen. Is it clear? So I will be using today fresh VMware virtual machine of Kali to do all this stuff. Let's continue on. So first, like you need to know what is the canvas. So for that, let me quickly bring up the slide. Just hang on a minute. I quickly bring up the slide over here on the screen. Yep, got it. So yeah, I will post the link. So check this out. This is the picture for our explanation that we will look today. So now if you see on the top left corner, you will be able to see the architecture of OSI model, like how the CAN. So basically in the car there are two kinds of protocol. One is CAN, which is nothing but a controller area network. Another one is OBD, onboard diagnostics. So basically OBD is nothing but more of the extension for a CAN protocol, and the CAN itself is runs on the three layers of OSI model: physical, the data, and the network. So and the OBT provide the transport layer. So it's like for OBD is used for the debugging of your electronic devices inside your car, and it runs on the CAN. Then vice versa, you can say. So what is the CAN actually? So when you think about a CAN, just like a nervous system inside your own body, like your brain is connected to, heart, or you can say your brain is able to control. Actually, I have posted a link for the poster. I have posted in the chat, you can check it out. Okay, let me share on my screen. Okay, wait a minute, just what happened to my stream is running. Oops. Oh, here you go. Yeah, now you can see on my screen the poster. Okay, yeah, let me increase my volume as well. Now can you hear me clearly? Is it my sound low anymore? I have increased the mic. Cool, let's continue on. So now, yeah, on the top left corner of the poster, you can see the CAN and the OBD protocol, both on the OSI model, how they look like. So yeah, as I was explaining, CAN is like just like a nervous system in, like just like in real biological human body. Like let's say your brain controls your hand and legs, just like that. CAN is nothing but protocol inside your car which enables the communication between the electronic communication units. So actually when you, like let's say, unlock the car remotely, so what happens is your unlock system mechanism will be connected to this device called ECU. So ECU is a nothing but electronic communication unit. That unit will be connected to other ECUs inside the car. So let's say, for example, unlocking, you receive the radio signal and that radio signal will be processed by the one of the ECU. That ECU will send the door opening command to the doors ECU, and that ECU will send the electric signal to open the door. So basically all the decision making part will be done by the ECU. It's nothing but a electronic communication unit, and each of these electronic communication units talk to each other over the CAN. So you can see how, so CAN node is nothing but your ECU, electronic communication unit, correct? And there will be a microcontroller which enables the communication of CAN, and there will be a trans receiver as well. So it's like it all the communication happens over the wire. It's just like it's serial, just like a serial communication. So it doesn't have any more of the structure or something. It's very simple. It's just sends and receive data in sequential order, and it's based on like mostly timestamps. So like your and the address of the receiving. So we will see in the next over here. So these are the components of a CAN packet. When you send a CAN, you can it's a breakdown into these layers. So first one, let's see. Yeah. So first one is SOF. Second one is CAN ID. Third one is RTR. Fourth one is control. Fifth one where your actual data payload goes, and the sixth one is CRC. CRC, if you have studied electronic communication in your college syllabus or a university, you will know it's cyclic redundancy check. So cyclic redundancy check is to ensure your how much error is present and whether the message transmission is done properly or not. So SOF is nothing but a start of frame. It tells other electronic communication units inside the car that message is incoming. So when a packet is sent with SOF enabled, the all ECUs inside car will be try to listen to that packet. If their address match, which is nothing but your CAN ID. So CAN ID is like ECU address of the ECU. Is CAN ID is like a MAC address. It's not same, but yeah, the CAN ID is the same as MAC address. If we talk about the conventional networks and all kind of stuff, so you can compare a CAN ID with a MAC address, but it's not same thing. Like it's a analogy wise, you can get me what I'm saying. So yeah, CAN ID will be address of your electronic communication unit. So if the address matches, that ECU will act on that CAN packet. If it gets the packet with start of frame bit enabled. Next is RTR, remote transmission request. Allows ECU to request messages from other active ECU on the network. So RTR, it's like it's just request CAN packets from the other ECUs. So if this bit is enabled, it will try to receive the CAN packets from the other devices inside the car. Control informs the length of the data in the bytes, like how long the data is gonna be, like how much bytes it will be. And the data, it's your actual data you will be sending. It can be anything, it will be in hexadecimal bytes. Okay, so this data will be like, let's say if I talk about your dashboard inside the car, you will be able to see speed in various forms, like you will be see RPM, you will be see kilometer per hour, you will be able to see the data from your fuel gauge, such as whether it's full or empty, or have you turned on left or right indicator. So all of this data will be transferred over CAN, and that's how your car reacts to the stuff. Yeah, sure. I will let you know, George, which one to use the for the OBD and the CAN. The one there are two actually, which I know so far. One is for the Raspberry Pi you can use, and one is for Arduino Nano. It's called Nano Cam. So there are two of them. There are a lot of them. There are a lot of controllers out there. But yeah, I will post the links in the chat, like where you can purchase those. So let's continue on. So like why we are doing all this, you may be wondering. So basically this entire talk is based on, you can say, a post exploitation scenario. So let's say if you have a compromised car, any any feature of the car. Let's say now modern cars now these days comes IoT enabled, and a lot of cars have the browsers as well. So one scenario income there are, like in the older cars, like let's say if you have a USB port, and let's say USB port, if you inject the malicious file, it have the buffer overflow, and through the buffer overflow you are able to compromise that particular system, music system inside the car. Once you compromise the music system inside the car, you are actually connected to ECU network. So like it's basically just like when you compromise this in the actual pen testing, when you compromise a computer or a server inside the same network, you will be able to do enumeration and exploitation of other system connected on the same network. Just like that, in a car, when a system is compromised, you will be able to do anything with other systems as well, since there is a no security mechanism for transmitting this CAN data. There is no encryption involved as well. Like why, you may ask, why there is no encryption? It's, isn't it crazy to not to have encryption? So CAN is like very old protocol. If you ask me, it's like it's been there for around 1960s. Okay, so yeah, at that time people were not much concerned about these things, like the people will start hacking cars in the future. No one have a think that in 1960s that hackers will find a way to get inside the car and do all the malicious stuff. The so way the protocol designed for over years is like it doesn't have any encryption. It doesn't cares where the packet came from which ECU. As long as the address CAN ID matches, it will just run the process the data inside the data payload. That's all. It won't verify the origin of the CAN packet. It will just match it with the CAN ID. That's what it's care about at the most. So let's continue further. So yeah, what I was talking is like once you compromise the system. So this is the scenario, like an attacker and basically a bug inside the car. So attacker has a compromised one of the components inside the car. So what he does is he sends exploit for that particular ECU and can send commands. So can send is like you will be sending these commands to your any OS which supports the communication with CAN. Right now Linux has a good support for communication with CAN. I'm not sure whether you can do this stuff in Windows or not. If you can do, just let me know or post about it in the chats. But yeah, today everything we will see in the Kali Linux, because yeah, most of you guys will be using Kali Linux in day-to-day penetration testing scenarios. So yeah, uh, so what attacker does is it sends the exploit for that component and plus the can send command. how, and like your car will act accordingly. So before doing that, what we he will be doing is he will listen to the traffic can traffic inside the car once he compromises the system, and try to identify the can id. Okay, so if you know the can id, you can control that particular component. Let's example, you have a foot pedal inside your car which increases acceleration. Correct. So there will be like accelerator, clutch, and brake. So whenever you press any of these pedals, a can send command will be go through the engine's ECU. Engine is like when you press the acceleration pedal, what will happen is your ECU, one of the ECUs inside the car will send can send command to the particular ID. That ID will match ECU ID of a engine, and once that engine ECU receives the command with the data will be nothing but how much speed the engine should increase. And yeah, likewise the hacker would be able to control everything inside the car once after knowing all of the particular can IDs for each and every other components, like engine, or let's say door lock unlock, or let's say even like left and right or indicators. Yeah, so end goal is to nothing but make the accident happen. Correct. Like yeah, if you can make a car go off the cliff and rest in peace. So let's enough of theory. Now I won't bore you more with theories. Let's continue on with the actual practical. So yeah, to get the all stuff running inside your system, what we'll see today is just a basic setup. So this is not I'm not gonna do on the actual car, since obviously I don't personally own a car, and obviously the car is expensive stuff to mess with. Correct. So I'm not that brave enough to do that. So what I'm doing today is using this ICS sim. ICS sim is nothing but instrument cluster simulation. So it simulates the your CAN scenario in your own Linux machine. You can get it from the internet. Let me show you. Tarun, we will see in few minutes. Yeah, I'm showing how you will be able to do that. So for intercepting CAN packet using Kali Linux in PC, you will require the external hardware, and that hardware you have to connect to your car to OBD port. There will be a port given inside your car where you can connect that particular microcontroller. So let's. So ICS sim is available on GitHub. So basically, you what you have to do is you just clone this repository in your local machine and follow the installation instruction given here to set up everything and start doing your own lab setup. So basically, it's nothing but a simulator. It will look like this. Oh, let me start it again. It always have the GUI issues. Yeah. So you can see over here. Let me quickly open my Wireshark. So this entire setup is based on virtual CAN network. It's a not a physical CAN network that we are using. It's entirely simulated. You can see vcan 0. vcan 0 is nothing but our CAN network. Okay, let me just zoom in. Let me increase the font if possible. Fonts appearance, fonts, yeah. So now if I press if I press the forward key from my keyboard, which is up arrow, oops, not W. Oh, sorry, I forgot to launch the controller. So basically, you have to start the controls as well. So you will be able to input into that CAN network. Oh, now I need to switch to my record. Okay. Oops. What happened? Why you are not? Okay, we got some activity. So now you can see after starting your controls, you will be able to see your CAN traffic going on. So these are the all CAN traffic transmitted by your engine ECU. But still I am not able to see my control. It's strange. I am not seeing my controls. There should be separate window over here which opens after. I don't know why it's not showing up. Yeah, it's finally showing up. Yeah. So now select this window and you can, it's clearly shown here what key does what in that CAN network. Now you can see this. Let's increase the speed and see what the activity is going on the Wireshark. Let me open everything side by side. This, this, and this. Okay. Okay, fine. Now I press up arrow. You see the speed gauge is increasing, correct? And you will see the number of packets is being transmitted is also increased. There will be a change. And like if you can do the other stuff as well. So this is the basic example. So now we will continue on how you can find out the your engine ID. So what you can do is you can capture this as well. Okay. And yeah, so for this simulator the ID for the ECU is hard coded. So there are different modes to practice with. this virtual CAN setup will provide you the options, so you can increase the randomness of CAN packet to make it hard. There are multiple levels inside this ICS sim. You can set it up like there will be a difficulties you can set. So yeah, you can increase the difficulty as well. So by default, our engine ECU ID is, when you work with default settings, you can see it on C source code. Let me zoom in. Yeah, if you have any questions, feel free to ask in between. Yeah, it's Suvamoy Roy, it's possible for any cars. It can be done with any car which has OBD protocol. Okay, what happened? Ah, yeah, CAN ID you can see inside the Wireshark. Just a minute, let me show you. I don't know, my system is being very unresponsive today. I didn't expect to this happen. But yeah, if you are in InfoSec, there is always this, panoti you can say, which happens. Your technical demo tends to break, as always. Whether it's a DEFCON or a Black Hat, or whether it's a Plymouth's live stream, it happens. Is it my everything unresponsive? I don't know why. So what I means is basically you can just see the CAN ID inside the Wireshark. Wait, I don't know why. It's completely gone in unresponsive. Finally something. Let me stop few stuff on my. Yeah, I'm stopping some programs to free some RAM. I'm getting rid of the programs. Just a minute. It happens. No, I don't need to restart. Actually, I can just restart my. Okay, fine. We just switch to Wireshark window. For God's sake. Yeah. Let me zoom in. Okay, now it's bit responsive, luckily. Let me close this as well. Yeah. Uh, hmm. Just hang on there. Give me 5 minutes. I will do this. Uh, why system? Why you are doing this to me today? Stop working. Or else, let me just quickly post the picture for you guys. You can see it's a Wireshark screenshot. Yikes. Okay, get out, please. Ah, I don't know. My system is completely hanged. Uh, I guess I should switch to my actual, not the virtual one. I have actually another Manjaro Linux in my as a host where I have everything installed already. I'm a pausing stream over here. Okay, just a minute. I will be back. Give me 5 minutes. My system is hanging a lot. I didn't expect it to happen today, but yeah.
Can you hear my heartbeat calling? Can you feel the love we're falling? Just take my hand and take me home tonight. Throwing caution to the wind, I'll take a chance and let you in. Just take my hand and take me home tonight. We defeat all impossibilities. Yeah, you and me will take our hearts and run free into the wild. Into the running so fast, can you find me in the dark? Oh baby, close your eyes and listen to the beat of my heart. Take my hand, don't be afraid. A love like ours just can't be tamed. Take my heart, just feel the beat. We'll leave tonight and run free into the into the into the
Hello everyone, so I'm back. Sorry for the inconvenience. This will be more smooth. Okay, yeah. So this will be more smooth, I guess. So yeah, we will continue on with our stuff. Let me know in the chat if everything is okay, the connectivity and the stream. Now I'm back to my host machine. So this is Linux host. You should be able to see everything properly without any problem. Okay, fine. Let's continue. Where was it? Let's start our ICS sim. Oh, yeah, set up for vCam first, and then ICS sim with yeah. So you can check that vCam is up or not. IF config. You should be able to see vCam 0, which is virtual CAN network 0. Yes, Nikhil, it's Linux. I am running Monero. This is my system specs on screen. It's Linux. I'm using Black Arch on top of Manjaro. So yeah, our virtual CAN network is up and running. Now we can just start our ICS sim. with interface name vcan0. Let's start it. One here, and let's start another. Controls vcan 0. So these are our controls. Let's move it to another workspace. Oops. Here. Let's open our Wireshark. Sudo Wireshark. So now you should be able to see everything inside the Wireshark as intended. Yeah, we will discuss about all general questions in about cybersecurity at the end of the stream. Right now I'm just focusing on this car hacking. I will definitely give you tips and advices how you can start into the cybersecurity in general, like how I started and what was my story. Right now just let's focus on the CAN. We can, yeah. So you can see this STD is nothing but your CAN ID. So if you go through the source code, as I was talking about, yeah, icsim.c. Let's me just full screen this. So you can see the all CAN IDs which is hard coded. So this is for like giving idea like how the ICS sim works. So for a speed it's 0x22 sorry 0x244. It's in hexadecimal. So let's increase the speed and see whether we can find this CAN ID. Now we will use the CAN sniffer. So CAN sniffer is to sniff CAN packets. CAN sniffer, you can see all the options provided by CAN sniffer. So you can sniff on filter out the particular CAN IDs. If you suspect like if you see the Wireshark, let me increase the speed first. Where is the speed? Okay, here. And let's switch to Wireshark. Yeah, it's there. You can see 244. Again you will see 244. So if you just do 244 and search, no, let's search it. Where was the find? Yeah, you can find it 244, or like not a display filter. string. Yeah, you can find it in the Wireshark as well. You can find it as a string. You just, so it will search that inside your entire CAN packets. So you can see this all values. This is for our engine ECU basically. So it will keep on go like this. Yeah. So let's find out the change, the live changes in CAN sniffer. Let's start CAN sniffer. Okay, now we have to tell it interface which we want to sniff our traffic. So we will tell it as vCAN0 since we are using virtual CAN network. So it will display all the changes over here. But we have to remove all CAN IDs first. So for that you can just do -000. Let me quickly copy this, paste, gone. Now do +244. So we are listening on a CAN ID 244. Now let's increase the speed of speedometer and everything. Let me bring the speedometer over here. Okay, yeah, let me grab this and put it with this. Okay, not this. This is my stream window. Here. Now if I increase the speed, you will notice the hexadecimal value over here is also increasing, correct? If I release the foot pedal, you will notice the hexadecimal values are also decreasing. So it's a more of behavior analysis, to be honest. If you, all you have to do is various actions inside the car. Like when you are doing a CAN sniffing in a car, what you do is first you press a foot pedal and see its traffic in your CAN sniffer, and you see all the IDs which is responsible to that particular event, such as pressing a brake or pressing a accelerator, or showing left or right indicator. So it's more of manual analysis. Well, first you have to check it out in Wireshark. After identifying those IDs, CAN IDs, you can filter them out in your CAN sniffer. So CAN sniffer, then it will listen on those particular IDs which you suspect for that particular ECU, and from there you can finalize which particular CAN ID belongs to what functionality inside the car, whether it's pressing a brake or whether it's for accelerator, or whether it's showing left or right indicators, or for a door lock or unlock. Let's see the example of door and unlock. According to source code, what is the door unlock? Let's see. I'm being a bit lazy over here, okay? I'm telling you the values from the source code, but you can find them. If you are experienced enough, you can definitely practice with ICS sim. As I mentioned, it has many practice levels as well. Sorry, ICS sim. Yep. You can practice with various level L1 and L2.
up to watch. So door, it's this one. Let's copy it. So there are 4 doors inside the car, which this simulates A, B, X, Y. Okay, now let's start our scan sniffer again. -0000 to remove all of our CAN IDs, plus oh, not this one. What did I do? It's not, don't put it hexadecimal values directly. It's 411. My bad. It's 411 minus 0000 plus 411. Okay, why didn't show 411? Come on, what happened? Am I giving correct stuff? Why it's not able to identify the changes? Oh yeah, sorry, I have to do the inputs here, right? Yeah. Should be. Okay, this will. I don't know why it's not working for a door. Anyway, leave it. You know the entire concept right now. So yeah, what you do is you do the basic analysis in Wireshark. You try to relate all the CAN IDs which you suspect belongs to that particular component inside the car. Then you try to filter out with CAN sniffer, and you can add and remove those CAN IDs. And the CAN sniffer helps you to see the data in the real time. So what would be automated way to do this, if you may ask me? The easiest way to automatically do all this stuff will be with the help of Python script. So you can write the entire logic inside the Python and the ScapeI. So ScapeI is nothing but a packet manipulation library. So ScapeI allows you to interact with the CAN network as well. So latest version of ScapeI have a support for CAN. So yeah, you can see, check this out, example in ScapeI library, how you can send and receive data to the particular CAN ID. Let me zoom in. Yeah. So yeah, from this example you can see from a ScapeI library how you can send and receive canned data. So like you can select which CAN ID you want to work with, or what kind of data you want to send. So let's see the example. I have example in my blog post. Let me bring that up. Yeah. So this is the basic one. Let me copy it. So I have let me search this file. It should be there with me. So I have captured CAN traffic in the Wireshark, and you can process that packet capture with a Python script. Okay, yeah, it's there finally. So my code should be also there. Yeah, it's there, parspcap.py. So let's check the contents of that. It's same. So yeah, I am doing nothing but I had recently captured the Wireshark packets, CAN packets, and stored it to this file while I was running ICS scene, and identified the CAN ID of the speedometer. So basically with this Python script I am doing nothing basic data analysis, which is nothing but trying to identify what was the maximum RPM of the car and what was the minimum RPM of that car. So it's really basic Python script with the use of for loop and all, and the file library. So let's run this script. Oops, from the activate. No input script file. It's Python 3. Oh, why you are not able to? Oh, sorry. Yep. Not that. Okay, fine. Why you are not able to identify escape file? Or should I? Oh yeah, my fault. Actually, that environment I was trying to activate didn't have escape file. So it will go through the all CAN packets inside that pcap file. Okay, so in that pcap file, whatever the values for the speed will be analyzed. It's a basic math, not much, which is done by heavy lifting is done by the Python. It will take some time. Yeah, it printed out all speed values. So raw RPM data in hexadecimal values, all the decimal values which it fetched from that CAN ID over here, you can see. And the maximum RPM values was this, and the minimum RPM was this. This is like engine was in idling, like when I was not, pressing anything on the keyboard, for like it was on the 0. So yeah, we are reaching to the end of this talk. Any doubts and questions so far? Please ask me. Okay, so in real world, Ajay, so real world, as I said, what you have to do is you will have to have external hardware connected to your laptop, which will enable communication with OBD port in your car, and from that OBD port you will be able to send and receive a CAN traffic same manner. Like where did I hack? What do you mean where did I hack? Like did I hack a real car or something? Like the 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 thing in uh, the the entire demo I showed right now, it was a virtual CAN network, not the entire. It's like a virtual CAN network is nothing but a simulator. Simulator is made in the C program, the demo I showed for. But in the real world, if you are asking, it's more of the guesswork. Yeah, like I don't know if there is a tool like that to directly identify all the CAN IDs, but it's more of the guesswork. You have to, as I said, if you want to identify speedometer CAN ID, what you do is press a foot pedal in the car, okay, and then receive that traffic in your Wireshark, and you save that .pcap file for a later analysis. Filter out all the CAN IDs which you suspect as for a speedometer, because obviously for the speedometer you will see the values changing. It will like let's say you press the speedometer for increasing speed, you will be seeing the hexadecimal values which is also increasing. So it's, as I said, it's more of a behavior analysis. Like, you should compare the CAN ID as accordingly to the functionality which you are trying to identify. Like, if you are trying to identify door lock or unlock, there will be very simple values like 0 or 1 for, enable on unlocked and locked. So like if you have four doors inside the car, for example, your hex values will be like, for unlocking first door it will be like something like 01, 02, 03, 04. Whereas for speed and RPM it will be like, infotainment console. Okay, well, I'm not sure what is that. Let me check. I'm not. Yeah. So. Uh, yeah, you can. Yeah, you can change the speed in the dashboard. Yeah, for a speedometer, yeah, you will be able to change the speed inside the dashboard, but not actual one, because for changing actual speed inside the car you would need to know CAN ID of the engine. You are correct, Ajay. George, I am not sure about your question. Not much in. See, the to be honest, automotive security testing is not my main thing. I'm more into IoT security in general. Like, I just have the knowledge of CAM in perspective of, IoT pen testing as overall. I'm not much deep into automotive security. It's entirely separate subdomain of cybersecurity. I'm much into in generalized IoT security. So yeah, but I will do check it out your question, and if I am able to reply, I will definitely answer you back, George. Matthew. Any more questions? Oh yeah, so someone has asked me how to get started into cybersecurity. Like, for me, it was I have been doing this for a very long time, if you ask me. For forensics, yeah, obviously you need to capture the traffic. Like, you would need to have somehow you need to extract the traffic data from the car. Like, for a forensics, like, if you want to determine, let's say, whether you want to determine the car is hacked or not, you will obviously see the some anomalies in the, normal, like, let's say someone increases the speed to 100. Okay, so what that attacker will do, he will flood the entire CAN network with speed as 100. It will continuously post 100, 100, 100, 100. So, like, from the forensic perspective, you will know that it is never possible that speed will remain the constant, correct? So once you know the speed was remaining constant, you will able to determine, yes, there was an attack done on the car, because it's in real life it's practically impossible to do that, right? It's practically impossible to have 100 rpm for a longer time. Okay, so you will see the CAN packets going for a particular CAN ID with the hexadecimal value for 100 rpm. So from there you will know someone is continuously trying to broadcast on the particular CAN ID and the rpm, constant rpm value, to make the accident happen for that car via car hacking. So that will be the forensic perspective on that. So what happens is, the in the real world scenario, uh, let me show you the controller. So yeah, this is the canvas shield, so you can buy it online. So you, what you do is you can connect it to your external device such as Raspberry Pi. No, there are many ways, not just a USB port. I just give an example of one functionality which you can hack to gain access to the CAN network. So like you can also try to exploit a web browser as well. Like the modern cars, like such as Tesla one, comes with the web browser. So like if someone visits a malicious website and attacker is able to, exploit the memory corruption flaw inside the browser, then yeah, he can do like whatever which you can connect in the newer version of cars to the internet, or like which has a user input. Distance, no, distance doesn't matter. It depends like what is your attack vector. Like it's, if you are trying to attack the radio signals, like from, if you are trying to pen test from let's say you want to pen test whether the doors inside the car can be open with wireless signals, uh, that will be like the range of the, the car, how much how far, like it's usually around, for a radio signals for a car it will be like, let's say 100 or 200 meters, like yeah. But it depends. If you, if you talk about the web browsers and the internet connected functionalities, obviously distance is limitless. Anyone sitting around the any part of the world, and the car is connected to internet through some kind of functionality such as a web browser or anything, and the attacker is able to exploit that, then pretty much it's limitless. There is no distance. So more, it's like a more features you bring, more vulnerabilities will get introduced, to be honest. So yeah, you can buy this CAN bus shield. So this you can connect to your Raspberry Pi, and obviously Raspberry Pi supports Linux. Then you can install the support for a CAN networks, and then you can install Wireshark and every normal tools inside your Raspberry Pi, and listen to the traffic. There is also a thing called Nano Cam. It is a small badge. Yeah, this Nano Cam. So this is NanoCan. So NanoCan is another shield which you can put on top of it. You can put Arduino Nano, and you can do the wiring with the actual CAN network or a CAN microcontroller. So you can make connections like this. Its example is given here, like which wire will go to what. So you do the connection like this with your Arduino Nano and the MCP2515 CAN controller inside your car. Then you should be able to send and receive traffic between your Arduino Nano and your targeted OBD port or ECU, engine ECU, or like speedometer ECU, or any electronic communication unit inside the car. Any more questions? And yeah, for a cybersecurity advices, like what my personal advice would be, like stay curious and keep on learning new things. Never stop learning. Always learning, and always have a curiosity to know anything which is unknown to you. That's what I have been always doing, and the mindset which I am following. So yeah, you can read out my blog. Let me put the link, and you can follow all these steps again. Where is my YouTube stream? Here. So yeah, check that out. You can follow steps from there and practice on ICS sim, which is a CAN network simulator. So yeah, this was talk on car hacking. I hope you everyone enjoyed. I hope you liked it. The concept behind the, it's a very simple, to be honest. It's not much complex. If you are, no, it's the only one which is easily available right now. I'm not sure if there is any other one, but this is more, this is the exact one which people use in Black Hat and DEF CON trainings. Yeah, pretty much anyone teaching you about the CAN stuff will ask you to install ICS sim. So yeah, I hope you all guys enjoyed today's live stream and you learned from me something new. And I'm really sorry, the at the start we were lagging a lot because of my system issues and issues with VMware, but I was lucky enough to quickly switch back to my Linux OS and work as normal and efficiently. So yeah, once again, thank you so much for Plymouth for giving me this opportunity to talk about introduction into car hacking and the canvas. And yeah, I'm looking forward to such a opportunity in the future again. So once again, thank you all whoever watched me with me till end, asked me the questions and queries. You can reach me out on the Twitter as well. My Twitter handle is CJ Hackers. Let me post it in the chat. You can reach me out on Twitter, and my name is Chirag Jariwala. You can also find me on LinkedIn, Twitter. Whenever you have doubts in the cybersecurity, I would love to help you out. I'm always open to teach people new things and mentor them, because we are in this all together, correct? So yeah, I'm gonna end the stream. Thank you very much again, and stay safe during these harder times, and use this opportunity, the current pandemic, to learn many things in your free time, because it's a right time to do that. Why? Because whenever you have a hardest times and a hardest situation in your life, you actually use that time to prepare for a more harder times which may come into the future. Like it's like sharpening your axe and skills and abilities. That's how you use the time. Okay, so yeah, goodbye all of you, and have a nice evening.